Hello students, today we are going to study the chapter Transition and Inner Transition Elements from Chemistry first. All of you know the periodic table. Periodic table consists of 119 elements are there, and these elements are divided in 4 blocks in periodic table. These are S block elements, P block elements, D block elements and F block elements. All of you know the electronic configuration, position and properties of these elements which is present in these 4 blocks, which is studied in 11th standard. Today we are going to study about the transition elements, that is transition elements, which is known as D block elements. D block elements. All of you know S block elements are present in first group and second group, which are alkali metals and alkaline earth metals. P block elements are present in 13th group to 18th group, in which metals are there, non-metals are there, metalloids are there, halogens, noble gas, all are present in the P block elements. Then F block element consists of lanthanoid and actinoids. Then D block elements, which is known as transition elements. Today we are discussing on the transition elements and as well as inner transition elements. Transition elements are nothing but these are D block element. See here the concept of transition elements. These elements are present in the middle of the periodic table, which lies between S block element and P block element. The properties of these elements are also lies between S block and P block elements, and the physical properties, reactivity and other chemical properties are gradually increases from left to right in D block elements also. And these are lies between S block elements and P block elements, therefore they are called as transition elements. Then what is D block element? What is the definition of D block element? Why they are called as D block element? See here, the D block element, the element in which atoms are, in which n-1d orbital of the atoms are filled progressively. That means here n-1d orbital, that means last orbital in which electron is orbital is n-1d. N means valence orbital, or it is also called as ultimate orbital, and n-1d orbital, that is penultimate orbital. That is the elements in which n-1d orbital, that is penultimate d orbitals, are progressively filled or successively filled, are called as D block element. That means the last electron, differentiating electron in those elements, atoms of those elements enter into n-1d orbital. Therefore these elements are called as D block elements. All of you know the general properties of these D block elements. Generally they shows variable oxidation state. Their n-1d orbitals are progressively filled up. Their colors, they are colored, or their solutions or their compounds are also, aqueous solution of their compounds are also colorful compounds or colorful solutions. Then all of you know the position of transition elements. The position of transition elements, that is D block elements, in periodic table. These elements are present in 3rd group to 12th group. That means these are present in 3rd, 4th, 5th, 6th up to the 12th group, and these are also present in 4th period, 5th period, 6th period and 7th period. That means D block elements are present in 4 series total 4 series. That are 4 transition series are there. Fourth period transition elements are known as 3D series elements. These are known as 3D series elements. Fifth period transition elements are called as 4D series transition elements. Sixth period, the elements which is present in sixth period is known as 5D series transition elements, and the elements which is present in seventh period are called as 6D transition series elements or 6D series elements. See here, the elements which is present in 3D, that is from scandium to zinc, having atomic number scandium 21 and zinc atomic number 30, which is known as 3D series elements. 4D series elements, yttrium, Y, that is 2 cadmium. Here 5D series elements, which is from lanthanum to Hg, that is mercury, and 6D series elements are from actinium to curium. Then all of you know the general electronic configuration of D block elements. You have studied in 11th standard, that is general electronic configuration of D block element, that is n-1d 1 to 10. That means n-1d orbital, if it is 3d, 4d, 5d or 6d, the electron present in it, that is 1 to 10, that means this orbital is progressively filled, and 4s orbital which is completely filled, that is 4s2, or here ns2. And the general electronic configuration for 3D series, according to this configuration, this general electronic configuration is for D block element. Concentrate here, that is n-1d 1 to 10 and ns2 is the general electronic configuration for D block element. Similarly, we can write the general electronic configuration for 3D series element, that is 3d 1 to 10 and 4s2. Similarly, 4D series transition elements, the general electronic configuration for this is 4d 1 to 10 and 5s 0 to 2. That means here sometime 5s orbital, there is electrons present in this orbital is 0, 1 or 2, isn't it? Then the general electronic configuration for 5D series transition element, that is 5D 1 to 10 and 6s2. Similarly, for 6D series element, the electronic configuration is 6D 1 to 10 and 7s2. Then see here, these are the 4 transition series of transition series. We discussed detail about the general electronic configuration of 4 transition series elements. 3D transition series element is also known as first transition series elements, in which it ranges from scandium 21 to zinc 30. There are 10 elements in first transition series element, that is 3D transition series element. We have to discuss detail about on this series element later. Then first see here, 4D series elements is also known as second transition series elements, in which yttrium 39 to cadmium 48 elements are there. Third transition series element that is known as 5D transition series element, in which lanthanum, that is 57 atomic number, to mercury Hg 80, in which except 58 atomic number element, that is cerium to lutetium, are present in inner transition elements. And similarly, fourth transition series element is known as 6D transition element. There are elements actinium 89 atomic number to curium 112, except thorium to lawrencium, which is having atomic number 90 to 103, which is inner transition elements. All of you know the general electronic configuration of first transition series element, that is 3D series element, in which scandium 21 atomic number to zinc 30 atomic number elements are present. The nearest noble gas to the scandium is argon. Argon 18 is the atomic number of argon, having electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p6. Then which having the completely filled orbitals of the element argon. Therefore, we have to write the general electronic configuration for 3D series, that is first transition series element, that is argon having atomic number 18, 4s2 and 3d 1 to 10, that means 3d orbital, that is n minus 1d orbital for this series is 3d, and 3d orbital is progressively filled, in which electrons are filled from 1 to 10. Then we will study detail about the first transition series elements, that is 3D series transition elements. See here, first of all we have to learn about the electronic configuration of first transition elements. All of you know the general electronic configuration for 3D series element, that is argon 18, 4s2, 3d 1 to 10. Using this general formula, we have to write the expected electronic configuration for first transition series element, that is 3D transition series element. Then first of all we have to write the elements scandium to zinc. The symbols of these elements are have to write here, that is scandium Sc, titanium Ti, vanadium V, chromium Cr, manganese Mn, iron Fe, cobalt Cu, nickel Ni, copper Cu and zinc Zn. Atomic number of scandium is 21, titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29 and zinc 30. Then expected electronic configuration for these all elements we have to write here. See here, argon having 18 electrons have to write first, then the remaining electrons are present in 4s orbital and 3d orbitals. See here, 18 electrons which is present in the scandium having the electronic configuration like the argon, and for next 3 electrons, the 2 electrons first entered into 4s2, then 1 electron enter into 3d orbital, that is here 3d orbital is incompletely filled and last electron enter into 3d orbital. Similarly, expected electronic configuration for titanium, that is argon 18 and 4s2, 3d 2. There are 2 electrons enters into 3d orbital. Vanadium, electronic configuration for vanadium, that is argon, 3d 3 4s2. Similarly, we can write the expected electronic configuration for the next all elements present in the first transition series. For chromium, it is 4s2 and 3d4. For manganese, expected electronic configuration, that is argon, 3d5 and 4s2. For iron, argon, electronic configuration, expected electronic configuration is 4s2 and 3d6. For the next element, that is cobalt, expected electronic configuration, it is argon, 4s2 3d7. For nickel, it is argon, 4s2 3d8. For copper, argon, 4s2 and 3d9. For zinc, it is electronic configuration, that is argon, 18. Remaining 11 electrons, out of these 2 electrons enter into 4s2, 12 electrons, 4s2 and 3d10. Focus here. 3d orbital for zinc is completely filled, but in other elements 3d orbitals are incompletely filled, that is it is progressively filled. Therefore, these elements are known as transition elements or d block elements, but zinc is not considered as a d block element because 3d orbital of this element is completely filled. Then actually observed electronic configuration means actual electronic configuration, that is spectroscopy electronic configuration for scandium is similar, same to as expected electronic configuration. For titanium, it is also same for these all, but only there is anomalous electronic configuration, that is observed electronic configuration and expected electronic configuration are different for only chromium and copper. All of you know about this, all of you studied this in 11th standard. Why? Because here one electron from 4s orbital, that is jumps into 3d orbital and makes that orbital half filled, isn't it? Therefore, electronic configuration, observed electronic configuration for chromium is argon, 3d5 and 4s1. Here one electron from 4s enters, promotes into 3d5 to make that orbital half filled and the element becomes stable. Similarly, there is expected electronic configuration and observed electronic configuration of copper is also different. Here also one electron from 4s is jumped into or promoted into 3d orbital and 3d orbital becomes completely filled, and therefore expected electronic configuration and observed electronic configuration of copper is different. That is, observed electronic configuration for copper is argon, 3d10 4s1. Therefore 3d orbital here becomes completely filled. Remaining all elements, expected and observed electronic configuration are same. Here, why this electronic configuration for chromium and copper are different? That means there is question which is that is chromium and copper shows anomalous behavior of electronic configuration or anomalous electronic configuration of chromium and copper is there. see here, one electron from 4s enters into 3d orbital for in chromium, because this 3d orbital becomes half filled, and all of you know the half filled orbital and completely filled orbitals and empty filled orbitals are more stable than the incompletely filled orbitals. If there are 4 electrons in 3d orbital, then last orbital, valence shell orbital, is incompletely filled. And instead of this, when one electron from 4s enters into 3d orbital, then last orbital, that is valence orbital, penultimate orbital, that is 3d orbital and 4s orbital, becomes half filled, and half filled orbital electronic configurations are more stable. To become stable, one electron from 4s jumps to the 3d orbital. Similarly, in copper, one electron from 4s jumps to the 3d orbital. In observed electronic configuration, there are 9 electrons, which is incompletely filled 3d orbital. But when one electron jumps to the 3d orbital, then 3d orbital becomes completely filled, and all of you know the completely filled orbital is more stable electronic configuration. To become more stable, copper and chromium shows anomalous electronic configuration, and they have different expected electronic configuration and observed electronic configuration. That is about the electronic configuration of 3D series, that is first transition series elements. Then we will discuss about the other properties of 3D series elements, and you can write using general electronic configuration for 4D, 5D series elements, 6D series elements. You can write the observed and expected electronic configuration for the elements which is present in 4D series element, 5D series elements and 6D series elements. That is about the total electronic configuration about the transition elements.